It's frozen there. Okay. Ready or not. All right. Did you finish both? Okay, I'll give you a little more time. Okay, we'll go over this in about 20 seconds. If you didn't finish it, that's fine. Okay, first of all, let's talk about some vocabulary. What's a sequence? What does that even mean? Yes.
It's like a list for like plugging something in with that and like the changes like and the list
Okay. Yeah, a sequence. Are we okay with that just being like a list normally of numbers? Of course, in this class, it's going to be numerical. And this, thank you. This word here, how do you pronounce that? Arithmetic, exactly. As opposed to, it's weird to hear that, isn't it? Arithmetic is a noun, arithmetic is it's an adjective, it's describing the sequence. And by definition, an arithmetic sequence is a sequence in which they go from one term to the next. There is a common difference. Does that sound familiar? Okay. So who'd like to tell us how they did number one? Yes, Ron.
So you can like subtract 439 and then under that well like and then you divide that by like 8 minus 3
Okay.
and that will get you like in most cases the slope and it's like the common difference.
Nice. So this gives you a seven, so that's a common difference.
Yeah, and then the way we were taught to like set it up is 7 times and or x minus 1. And
Like
then
this.
yeah, and then you can and then plug in like out of like then you can plug in if it was 3, what do you get? And then you can subtract it in the way it's good.
If it was three, if what's three?
Like it ends. And
Okay, so like if so it sounds like you were given a relationship a sub n equals what was this? A sub one. Does this look familiar? Is this what he did? I'm not sure. A sub one
plus the
plus
um,
the d times n minus one. So I think that's what you're talking about, the n minus one. Okay. So you're saying we found d, so we could say something like a sub one plus 7 times n minus one And then what were we saying from here?
You can change the AN to, 4 and the.
So when n equals 3, we get that 4 equals a sub 1 plus 7 times 3 minus 1. Is this what you're saying, if I'm following it correctly? So this gives us an equation that we could actually solve. Okay, so what's this? 4 equals 81. A sub 1 plus 14. So a sub 1 equals -10. So the general formula, a sub n is equal to -10 plus 7 times n minus 1. Are we good with that? Do we have to multiply that out? You can if you want to. I think this is fine as a general formula. Another word for general term, did he tell you another word for that? Explicit. Meaning if you want the 100th term, all you have to do is plug in 100, right? I guess it would probably be easier to find the 101st term, wouldn't it? 101st term is actually pretty nice in this form, but it's not too difficult to find the 100th term. Okay, so that's explicit formula or the general formula or general term of the arithmetic sequence. Are we good? Can someone explain to me what this here means? What is that? Yes, Feliciano.
Yeah.
Very nice. Are we good with that? So if I want the 100th term here, if I want a sub 100, according to this formula, first I need to find which one? I need to find the 99th term. And how do I get the 99th term? I have to get the 98th term. So it's very different from the explicit formula. It's built on a previous one. So generally we start with the first one and then we build there. So if the first term is 4, did you get the next one? 7, are we good with that? This is just saying if you want any term, you take the previous one and add 3. So for the second term, you look back here and say, I'm going to add 3 now, plus 7. Here plus 3, which means the next one is, of course, 10 and 13. Are we comfortable with that? Cool. From here, I could also rewrite this relationship and say an minus a sub n minus 1 is equal to 3. I don't know if he showed you that relationship. And minus and so a sub n minus a sub n minus 1, that is just the common difference. That's another way of writing that there. Common difference. Okay, let's move on, shall we? To the packet, day 2. We're going to start with a motivating example. Quentin has a secret. On the first day of school, he tells his closest friend. On the second day, they each tell the secret to someone else. Each person that hears the secret shares the secret with a new person each day. Take a minute to look at A, B, and see if you could do the whole thing. Make sure you're getting the same thing your neighbor did for number 1A. For example, 1A, excuse me. Okay. First day, how many people know it? Two. Second day. Does that make sense? Four. Third day, 8, and then fourth day is, of course, 16. Yes. Right, each person's telling one person that open day 2 to day 3 is people who know. B, how do we get this? Just double it, right? 1024 times 2 gives us 2,048 students. Is anyone else uncomfortable with all of this? Or what's wrong with Quentin? Right? And what's wrong with everyone telling these secrets? And how did these 1,024 students find another 1,024 who didn't know the secret already? How they find that? How they know? There's just strange things going on at this school. Not our school, but whatever's happening here with Quentin. And Quentin tells a secret every day. Some secret. Write an explicit rule for the number of students who know the secret on day N. Did anyone get this? Anyone? Anyone? Rolling for 400? Say that again. Let's say N, 2 to the N power. And since it's a explicit rule, I need to have an equal sign in here. So we'll say that like A sub N is equal to 2 to the nth power. Is this what you were thinking already? It's just repeated multiplication of 2. So that's 2 to however many times it's multiplied by. Go ahead and graph this if you haven't already. What happened on day 0? How many people knew that? Then just one, right? Just Quentin knew. Because it was day 1 when he shared. So before he shared it, we could consider that day 0. Do you recognize this shape?
Yeah, it's like a half parabola.
Seems like half parabola. Would it be appropriate to connect the dots? Why not?
It's not only the boards.
Because what?
It's only like the board stuff. You can have one and a half.
We can't have what? Well, I think this is counting days, it's like 1 day, 2 days, 2 days, but yeah, counting other than there's never like 2.2 people knowing the secrets. Yeah, in between people, and in between the days, I think it's just doubling per day. It wouldn't be quite appropriate to connect these dots. So we haven't studied the shape yet, but it does appear to be like a parabola. We'll tuck that away. So geometric sequence. The sequence of numbers we just talked about is a really good example of a geometric sequence where it doesn't have a common difference, but does have something else that's common here. Right, we went from 2 to 4 to 8 to 16. What do you think it would be called? Maybe quotient. That's a good guess. I'll just write a sequence that has a common ratio. That has a common ratio. from term to term. I'm going to be adding more to this definition as we go, but that's really all you need to know. Have a common ratio. In other words, you multiply by the same thing each time. Okay, so example 2, there are 5 different possibilities here, or 5 different examples. It's your choice, arithmetic, geometric, or neither. By the way, if it's arithmetic, I want the common difference. If it's geometric, I want the common ratio, if you could figure that out. If it's neither, don't give me either one of them.
What is geometric?
Geometric, I want the common ratio.
Which is like.
Like, how do you go from one? Not the, how do you, well, let's talk about A and then look at it. Yeah, sure. Yeah, that's a lot of words there. Okay, A, what kind of a sequence is that? It is geometric, of course. So this is geometric. Do you see what the common ratio is? I thought this R is 2. Do you see how that makes perfect sense? If this would have been 5, 15, 45, then the common ratio would be 3. We'll talk about where that comes from. Okay, so again, for B, C, D, and E, I want to know what kind of sequence it is. I want to know the D or the R associated with it. And B, of course, is what kind of a sequence? Arithmetic. And which means it has a common difference of -5. We're good. And a common difference just comes from saying, where do we see that -5? Can't be any two. Here we could just say 7 minus 12, or 2 minus 7, or -3 minus 2. See, what kind of a sequence is that? Geometric. And that means it has an R, which is equal to 1/2. Do you see it? The same thing, just instead of subtracting, you take it, turn and divide it by the thing, divide by 25 divided by 10. This is not as good, but I'd also do this 1/2. Or you just say, hey, look, we're multiplying by 1/2 every time, which is, I guess, what you did. Maybe. D, what is it? Geometric with a common ratio of -1/3. Was E anything? So it's a neither, right? Maybe? Is it what? Both? Maybe both. Hmm. Neither? Yeah. How do you know it's arithmetic? Oh, did you write a few terms or something? Nice. Yeah, if you're not sure, I recommend writing a few terms, but I like your logic here. Like, I know the first term would be A sub 1, which is 2. Second term is that clear? Is this enough to decide if it's arithmetic or geometric or neither? Definitely not. We need at least 3. So let's do one more. So A sub 3 gives us a, what, 3 plus 3 is 6 divided by 2 is something like 3. Does it appear to be arithmetic? Yeah, arithmetic with a common difference of 1/2. So now that we've done this, I'd like to add a little bit more to this. Ratio cannot equal. There are two numbers that it cannot equal, but one of them is obvious. 0. Does that make sense? 0. Wouldn't it be a common ratio? Because if you have something like 0 times, well, 0, 0, 0, 0. Yeah, common ratio is 0, but isn't it also 100? Every time you multiply by a number, it's 100. Each number by 100, it just doesn't work. Right? It's just not good. So 0 can't be part of this. And there is one other number. R can't equal 1. Nice. Right, like if we start with 5, and this is a geometric sequence, it'd be 5, comma 5, 5, 5. It's just not, it doesn't fit the pattern. Because that could also be arithmetic, couldn't it? With a common difference of 0. So it's either got to be 0 or 1. To get the common ratio, we always take a sub n and divide it by the previous term, which we call a sub n minus 1, always. And I'm going to build the explicit here. At the bottom, let's see. I'll do this. Dot, dot, dot. This first term is a sub 1, second term is a sub 2, a sub 3, a4, a5. And this one's a sub n. Since this is geometric, first term is just a sub 1. Second term is a sub 1 times r, since it's geometric. Yes? Now, a sub 3, I could say a sub 2 times r, but I want to relate it to a sub 1. A sub 1 times is 2r. Are we good with that? R squared? Let's see, to get there, we had to do times r and then multiply by r again. That's a1 times r, which is the same thing as saying a sub 1 times r squared. For that fourth term, that's going to be a sub 1 times r cubed. I think I'm getting a hang of this. A sub 1 is, so a sub 5 is a sub 1 times r to the fourth power. Could you please write an expression for a sub n? And check with the neighbor. Anyone get it? Who'd like to tell us? Rolling for 500. Are we good with that? Does that n minus 1 sound familiar? Kind of same thing as the arithmetic. So what we've just done here is built the explicit formula. The a sub n is equal to a sub 1 times r to the n minus 1. I'll give you a moment to do example 3. I'd like to call someone for this. Are you ready? Okay, McKenna, we know the first term is 10. Can you tell us the next four? $2,560. Okay. Are we good with these?
Yeah.
Can I answer any questions? Thanks, McKenna. Okay, find the explicit form of the given geometric sequence. Okay, I'm gonna call on someone in just a moment. Make sure you discuss with the neighbor.
Ready? Alright, let's help with this one. Where did that one of three come from? Are we good with that? Perfect. Yeah, and to get that already, you can just pick any number and divide the previous one. If it's not as obvious as it is, 565, 865, 615, and, you know? How much do you have? This is great. Do you agree that this is appropriate for this problem? To get a term, need to use the previous term and divide it by 3. We just have to make sure that we know that a sub one, and we need something to build off of, is equal to 18. Yeah. So this is really good, except for one thing. The question asks for explicit, which means if I want the 100th term, I should just be able to plug it right in and get it. So this is really good. What is this form called here? The second one? The first one is explicit for general. Second one is called recursive. Nice. So if it were asking for recursive, that'd be perfect. Okay. For B, Keisha, what did you get? Where did that negative 1/5 come from? Multiplying by. Okay. It's easy to see. Are we good with that? And if it isn't easy to see, all you have to do is take any term and divide it by the previous one. Is that really nice here? Negative 1/5. It's right there. Give it a second. The third term. Negative 1/5. Thank you. And finally, well, not finally, for example, 5. Go for it. It's too crazy to leave it in calculator ready form. On something for A and B, pretty soon should have answers. Luciano, what you do for like 80? So. Well, let's start with you said 8. Are we good?
Now to get 2 to the 7th, is that difficult? Do you guys use your fingers for that, 2 to the 7th? I do recommend it. And thumb is 2, then every other finger is, not every other, but then 4, 8, 16, 32. Does that make sense? Right now at 2 to the 5th, 64, 128. So we could do 6 times 128.
Do I care if you can do 6 times 128 if this were a test? I care that you're able to do it, but if time is short and you don't have your calculator, then you're happy that you got the answer and it's calculated. At least now I think did you get the final answer?
One chance? Okay, leave it.
I think it was
Okay, no problem. And for B, Karen,
it's kind of like this about,
okay,
I thought, A1,
So 8,000 times negative 1/2 to the which power? 19 power. And this is ridiculous to try to do by hand with all this thing. So we probably just leave it like that. But is this answer positive or negative? It is negative because 19 is 5. And example 6. Thank you, Ken. Example 6. New iPhone is purchased for $799. The value of the phone decreases by 33% each year. How much is the phone worth 5 years after its purchase? Discuss wisely in this section.
what we're. Well, they were having sex there, yeah.
Okay. Let's talk about the first year. When it's due at $799, 1 year later,
it's 799. What do I do? So besides rolling first. Yes, Lucas.
I would 799 times 2 over 3, give it n minus 1.
Does 2/3 make sense? Why 2/3 if it's 33%?
It goes down by the 80% of the years.
Yeah, it's maintained 2/3 of the price. Nice. So you could multiply by, right? If you do this, if you multiply by 1/3, then you're actually finding the amount that you subtract, right? We want to know how much it's worth, so it's the rest. Nice. And then you just, so since this was the 5th year, you just raise this to the 4th power. Are we good with that? Nicely done. Thank you. It doesn't really say 1/3 though, does it? It seems like 1/3, so maybe instead of 2/3, we could call this, what might be more appropriate since it's 33%, not 33 and a third. Yeah, or just 0.67. Maybe that would be like exact to this problem, make perfect. Any questions? Lucas, thank you for your help. Perhaps your question is, can we spend some time on the assignment? If so, the answer is yes.